in a project, basically what you do is this. Okay, first you do a bit of, you select a topic. Okay, the first thing is select a topic. So I have already given you a topic, right? Select a topic, that's done. Okay. Number two, you will basically do a literature survey. Literature survey. Okay. Now literature survey, you know, there are different ways of doing literature survey. You can do it from some paid resources like Web of Science and all, but then in general, what we do is we use Google Scholar most of the times. Okay. And WhatsApp also. So in the search engine, you just type Scholar, okay, and then you can just go for Google Scholar, and then you have got this. Okay, so here everything is more or less related with research. The papers are research papers here. So I just check the topic here. Let's say the first topic which I've given to him, something synthesis of Zedono nanoparticle using chemical co-precipitation method. Okay, so before you really start with the literature survey, you should actually know the definitions. Okay, so maybe I can just put a point in between, know the meaning of topic, in the sense that what do you mean by what are Zedono nanoparticles, what is co-precipitation method. So if you know about these things, probably you can just find out your papers more easily. So in general, when I say nanoparticle, this is nanoparticle, this is nanoparticle, this is nanoplates. Okay, so nanoparticle is something which is three-dimensional in nature. It's a particle. SNO2 nanoparticle, it's again three-dimensional. It's a particle. Okay, but then when we say nanoplates, it is two-dimensional. That means you basically are having a structure like nanoflakes and all. So it's two-dimensional. It's around x-axis and the y-axis. The thickness is fixed. Okay. But in nanoparticle, it might be something which is spherical in shape. Okay, how do we know what is the shape of these particles? Using some techniques like SEM, TEM, and all. Okay, so this is something which you come to going later. This is something which you have already studied in experimental technique, and so this makes very much sense that you're doing a project now because you already know about experimental techniques. Okay, so let's say I know the meaning of the topic selected, so I know what are Zedono nanoparticles, zinc oxide nanoparticle. Chemical co-precipitation method is one of the easier methods. Let me just go back. Okay, meaning of this. Okay, so you know, chemical co-precipitation method is basically a technique which can easily be used in the lab. Okay, and usually doesn't need much of a setup. And the process chemical co-precipitation or sol gel or hydrothermal method, usually you can synthesize your sample very fast. Doesn't take much time. Okay, now let's just go into literature survey and Google Scholar. So what you do is usually you go here and then you can actually paste a part of the topic. Paste a part of the topic. Okay. You can paste a part of the topic, or maybe you can paste the entire thing. And I will just take up this. Okay, Zedono nanoparticle using chemical co-precipitation method. Okay. So if I just copy this, okay, and then maybe I can just paste it here. Paste this plain text. Okay. So I'll just click. Okay, so you know you will get so many options here. Someone has checked magnetism of manganese doped Zedono nanoparticle by co-precipitation method and so on. Okay, so you can just check for the papers and see which suits best. Whenever we are doing any kind of research, it's important that we have all the chemicals available. Now for Zedono synthesis co-precipitation method, the chemicals are available. Okay, and you know you should not check too old papers. It should not be a very old paper. What you do is you basically check the range here. So what I can do is I can probably click on this custom range, and maybe I can just check it from the since we are doing it for a minor project. So I don't prefer or tell you that you take too much of a new paper. But what you can do is you can check from 2016 to 2021. Okay. So you have a paper which are latest. Okay. And then you do is basically you can just open. So see, synthesis, structural and optical character properties of pure Zedono and CO2 nanoparticle prepared by the chemical co-precipitation method. Now the thing is, can you just select any paper, any random paper? The Answer is no, because you need to check which journal they're published in. Okay, so Springer is a good application, so you can consider this. Okay, at this stage. Okay, if you're going for even better work, then you need to consider even some selected journals from Springer, Elsevier, and so on. Okay, you cannot just take up any journal paper, because all the research work that are being published are not authentic. Okay, we need to believe that. Okay, this is a good journal, Material Science and Engineering C. It's Elsevier 2020. So, structural, optical, and antibacterial investigation of lanthanum, copper, dual doped zetano nanoparticles. So, they're not doping it. They are actually also preparing a pure sample. So, you can check this. So, you can just click here and then open it in a new tab. Okay. And then in this way, what you can do is you can actually select around 10 to 15 papers. Okay, and then you can see which paper you find that the chemicals are available, or maybe the technique sounds easy. Okay, or the processing or the time is less. Okay, usually in co-precipitation method the time is not much. Okay, so this is also a good journal, Material Research Bulletin. We can click here and then you can check the paper. Okay, so this is here. Okay, and access through here, let's see what access we have. Yeah, so access to National Institute. So I really don't have the access right now. Okay, we don't have the access, so I cannot download the entire paper. How do I download the entire paper is something which I'm going to tell you now. But before that, you can just go through the abstract. Okay, approximately you'll have an idea what exactly they have done. So in this particular work, that what they have done is they have doped it with lanthanum and copper. This is for all of you. Okay, this is something, an example which I've taken from the first project. But then you can just check. What is done is the XRD pattern has been studied. So that means they have synthesized the sample and they have studied XRD. XRD, do we have it in our institute? Yes, we have it. So that means this is something which we can do. Okay. In general, when we synthesize the sample, we need to characterize it. So it's not mandatory that whatever is mentioned, you need to do it. Okay, we can just characterize it and we can say that we have done structural and optical characterization. So whatever you do, we can actually investigate the structural and optical characterization. In structural, we take up XRD, which we have in our institute, and for optical, we can take up UV visible, IR, and so on. Okay, so we have these FTIR, UV visible, it's there. Okay, PL is there, and then we can actually use those. So we have already studied about these experimental techniques in our second sem. So this is something which should be used here. Okay, so what I want all of you to do is probably go through these abstracts. Don't read the entire paper right now. You can just do the abstract. See here, event-doped nanopowders. The ratio of this to this was successfully synthesized 0 to 3%. That means 0 means there was no magnesium. Okay, sorry, manganese. There was no manganese, only zetano, and 3% means 3% of manganese was there. So you can just know that obviously they have prepared a pure zetano also. So pure zetano, you can just how they have prepared. Okay, and then you can assess whether you can do it in the lab or not. We can do it or not. We can easily do it. Okay, it's not very difficult. So see, this is a paper which is free. This is free. This can be downloaded free of cost. Okay, so let me just scroll down and check what is this. Okay, so see, nanopowder synthesis, what they have done. They have taken up zetano nanoparticle at different magnesium, manganese percentage. Okay, by co-precipitation method. That's our aim. What is the project that I've given? What they have used is zinc chloride tetrahydrate. We have it in our lab. Manganese we don't need. We're not doping it. Okay, so that is done. So what they have done is to prepare this. They have taken this much gram of ZnCl2 and dissolved it in a beaker containing 150 ml of distilled water and 50 ml of absolute ethanol at room temperature. Okay, so they have not mentioned the entire technique. So you have to search a paper where the entire technique is mentioned. Usually, what happens is this zinc chloride is taken. It is basically dissolved in this, okay, ethanol, mixture of ethanol and distilled water, and stirred for some time. Okay, after stirring, okay, maybe you will have some precipitate. Okay, so the precipitate, what happens is you will have the liquid which will be at the top, and the precipitate settles down. Okay, and then you need to filter it out. So how do you filter it out? We can actually use a centrifuge tube already there in the lab. Okay, we have a centrifuge machine, and then you will have the powder which is there, but powder is still wet. So you basically have to dry it. So you can dry it around 60 or 70 degrees centigrade in the oven. We have it. Okay, and then you have to do the calcination. Okay, and the calcination is also very simple. And once you do it, whether your sample is Zetano or not, how do you know? You can just look into the XRD. So if you look at the XRD pattern, there will be certain peak, and this will tell you that your material is ZN. Okay. So what I'd like to tell you is now you have to do this. Okay. So you have to just find out the relevant paper, look into the abstract, and write down a similar abstract. But in the abstract, you will see. Please pay attention to this. Very important. In the abstract, they might have written that what is the result that they have got. You don't want to write down the result. You just say that what are we going to do. Okay. So if I just write it here, you have to literature survey from Google Scholar. So from Google Scholar, you can check some relevant paper, and then you download the full paper. Not for tomorrow's abstract submission. You can do that later when we actually start the work. So I don't believe in starting the work without doing a bit of literature survey. So please do the literature survey as fast as possible so that we can start the lab work directly. Download full paper. How do I download full paper? I'll again to Google. This is something which is not official in places. Okay? They keep on changing the website. There's this website SCI-Hub, and if you just type in Google, okay, you get a link. Click on the first link, and you have this website. Okay, and this is written DOI. DOI means Digital Object Identifier. So whatever paper you are searching for, suppose this paper. Now this paper, the entire paper is not available. You cannot download it. You need an institutional subscription. If you need it free of cost, what you can do is you can just scroll up. Okay, check for DOI. So this is your DOI. See, this is the entire link. And if you just want to get the DOI, you can just take the whatever is written after the front slash. Okay, so you have it here. I'll just click and select copy, and then I will paste it here. Okay, and then I will click on open. So if I do that, most of the times, sometimes it does not work. Most of the times you'll get that paper. So see, this paper gets loaded. Okay, it is getting downloaded from other servers of different institutes which are actually already having a subscription to this. So this is how it's done. Okay, it has got its own stories of controversies, this particular website. Okay, but then let's keep that aside. Right now I need information and I need the entire paper. So it will take some time to load depending on your internet speed, but then it works. Okay, it's totally fine. Use this, and accessible from your even from your mobile phone. So see, this is already available there. Okay, so this was published accepted in October 2019, and if you want to read the entire paper, you have it here. Now if you go for the experimental technique here, okay, you can just check here. Let me just go down. Okay, yeah, this is the result and discussion part. I'm not going to go for that right now. Just going to go for the sample synthesis. See the synthesis. So undoped this. So this is not doped, just Zn and lanthanum, and then they have used copper from 0% to 4%. Okay, so you can just leave aside this lanthanum chloride and copper chloride aside, and just think about zinc. Okay, so you can see that what they have done is basically this. Okay, see the technique here. Has been prepared by co-precipitation method using zinc acetate. So zinc acetate is also there in the lab. We'll use it. Okay, zinc acetate is used, and in sodium hydroxide. So sodium hydroxide is available. You can take distilled water, and there are small pellets of sodium hydroxide. You can just mix it, and then you can get a solution of sodium hydroxide. And the solution of sodium hydroxide was allowed as dropwise to the initial solution to increase the pH to 10. So what happens is you have pH meter, or you have got pH strip. You can use that and actually make a solution and you adjust the pH to 10. And then a similar process of allowing the precipitate to settle down and then do it and so on. Okay, so this is what is done in this particular paper. So what you can do is you can just check the paper, and if you feel it's okay, it's relevant, you can just clear, and then download option comes in, and you can download the paper and then keep it in your records. So this is what is done for getting the full paper. But then it depends on what topic you have. Okay, so if I just go back to the topics that I've given you, so this is for ZNO nanoparticle using chemical co-precipitation method. Similarly, SNO2 can be synthesized using Sol-Gel method. Okay, so Sol-Gel method is slightly different. What happens this technique is the solvent that you basically make forms a gel kind of structure. Okay, Inside it will be a gel kind of structure. It might be not very visible that you look into directly a gel, but then you know the formation is gel type, and that's why it is called sol gel method. Something which is similar to chemical co-precipitation method, but the chemicals which are used is different. Okay, and finally for Rebecca, I have it as the hydrothermal method. So there is something which is called a hydrothermal reactor, and you can actually make ZNO nanoplates. So first thing is, what do I mean by ZNO nanoplate? So if you just use a SAM or a TEM, okay, and if you want to look into ZNO nanoparticle, okay, let's show you ZNO nanoparticle. ZNO nano. So if you just go for images here, okay, you will get the SAM and the TEM images, and then you know if it's a particle, it may be looking like something like this. Okay, might not be a spherical shape everywhere, but then this is something like this. This is a SAM image, and this is a TEM image, tunneling electron microscope. Okay, so if I just write down plates here, let me just replace it with plates. What structure you are synthesizing this? We don't have SAM TEM here, so you know you might not be doing SAM or TEM. So if you look into plates, it will be something like this. Okay, one might be like this. So you know this is already a technique which is one-step hydrothermal synthesis, optical properties of aluminum group, there is no nanoplate. So I can directly go from here into the paper, and let me check what paper is it. Okay, so this is basically RSC. Okay, this is actually one of the most reputed journals. Okay, and you know one-step hydrothermal synthesis and optical property of aluminum doped hexagon nanoplate. So this paper is here. Okay, you can check it. Okay, and you know this is the abstract that I have. So this is very much relevant for Rebecca. You can check it. This one. You can just go for Google search and find it. So you know the paper is here, but then you know the entire paper is not here. You don't know how they have synthesized it. So what I can do is I can click this. I can copy the DOI. Okay, and then here I can go back. Okay, and once I go back, I can click here, and then I can paste, and then I open. Okay. So once I open this, I will have the paper. Okay, and then I can check how they have exactly synthesized the sample. Okay, so let me just check this. Okay, this is written communication. So in general, when you have written this communication, means these are all short papers. Okay, these are not too long. Okay. So maybe the synthesis technique maybe not be mentioned in detail. Okay, so you have to read this paper and check how I have synthesized it. Okay, a lot of content we have to search for it, I guess. Yeah, I think maybe they have not mentioned it. Okay, anyway, yeah, in this particular para, so you can check it here. Okay, aqueous solution of HMT. HMT I think is also there in the lab. Okay, and then aluminum nitrate. I don't need to use this. I'm not doping anything. We're prepared using distilled water. The AL dopes are not prepared in the following mixture of precursor solution of 15 ml HMT. You take X millimolar. These measurements you need to know, but right now you can just continue with the abstract, and this you can understand at the later time. And then 50 ml of H2O were added to 50 ml of Teflon lined stainless steel autoclave. Now this term Teflon lined stainless steel autoclave is the hydrothermal reactor. Okay, so this is something which is being used. Okay, so maybe you can check this paper. Okay, and I'm just giving an example. You have to do it on your own. Okay, any research work needs to be done on the student side. So if I just show you an hydrothermal reactor, it is already there in the lab. If you're visiting the lab, you can just check it. Okay, it will be there. You can ask any of the research scholars to just show it to you. He or she will show it to you. Okay, not an issue. So this is the one. Okay, this is the one that you'll see. You basically have a Teflon cylinder. This is a Teflon cylinder. Okay, it basically can withstand high temperature. You know that's the property of Teflon. And then there will be something like this. Okay, it will be basically a stainless steel enclosure inside which the autoclave is put, and then this entire setup is put inside the oven. So it's under very high pressure. So slightest change in temperature will increase the pressure inside it, and the sample that you're synthesizing will be actually synthesized because of this high pressure and temperature. Okay, so this is how our autoclave look. We have it in our lab, around 2-3 autoclaves up there. Okay, then Rebecca will use it. So that's the main thing that I'd like to tell you. And for now, what you can do is just design the abstract. Okay, it should not be very complicated. So in abstract, what you do is, okay, anyway, before that, let me just tell you this. So now you have downloaded the full paper, and then you have done the literature survey. Okay, and then what you do is determine the synthesis technique. So you read the papers, and if you have written the synthesis process in detail means what chemical you are going to use and so on. You have written the abstract means you already know a bit about it, so it will help you out to synthesize the sample. Okay, and then you have to synthesize the sample in the lab. So then you synthesize the sample in the lab. Okay, that's the next process. And then what you do is you can characterize it. So you know most of your friends will characterize basically the samples. Okay, some of them might be sending it outside, but you know, for our work, I think it's okay. Characterize the sample means you have to do its XRD. Okay, and maybe I can just write it down in this way. Okay, you can just do structural and optical. And for this, you can just do the XRD, you can do the UV, you can do PL, you can do FTIR, okay, and these 4 characterizations should be okay. If you have time, you can do these 4, okay. I think you'll have enough time to do these 4. First, you have to synthesize the sample at the earliest. So as soon as you synthesize the sample, you can immediately go for characterization. And then whatever you have studied in your second semester in experimental technique, everything you have to use it here, okay. So this is basically a general flow that you do basically in the project. And when you write down your final report, you have to do a lot of things here. Okay, so before the final report, probably you have to write down the abstract. Okay, so in abstract, I just remember few things here. Okay, you have to write down the title. So title I've already given. Okay, synthesis of xenon nanoparticle using Co-Precipitation method. Okay, but then you are also characterizing it. So synthesis and characterization. Okay, so probably I'll change this topic a bit, and I will include this word of characterization, because you are not only synthesizing, you are also studying the sample, so you're characterizing the sample. So you can just add this. Okay, so this may be the title of your paper. Okay, and then you have to write down the title. So title is already done. Okay, and number 2, you have to write down the abstract. So abstract should not be short. Okay, it should not be too short. What I would suggest is you write down around 150 to 300 words. A bit more is okay, still fine, not a problem, but then don't make it too short. Okay, I will just still ask the format. I'm still not sure. Okay, how many pages? I think only 1 page abstract. Okay, the format that is being followed now is Times Roman font. Okay, and it will be around 13 size, font size, and then it will be 1.5 spacing. So all of these things you have to do it on your own. Okay, it's always better you do it on your own so that you understand and learn it. Okay, if you don't have a laptop, you can actually do it in your mobile, but you know at this level it's important that you have a laptop. In case you don't have a laptop, you can use the desktops which are placed in the department. Since you are already in campus, it's there in the lab in the balloon cells chamber. You can use those computers. An issue. Okay, you can come anytime and use it. The lab is open late. Okay, research scholars are already there. So this is what you do exactly. Okay, and then in the abstract you basically just write down that what exactly are you going to do. Okay, so maybe you can just write down the plan of work, how you're going to synthesize the chemical co-precipitation method, what are you going to synthesize, you know, and so on. And then characterize. Okay, so what are you going to use for characterization, the XRD and all. If you mention that you are going to use XRD, you have to do XRD. Okay, and then expected results. So maybe you can write down that we are expecting that we'll synthesize nanoparticle and so on. Okay, this is what you have to do basically in abstract. Okay, and then finally what you can do is probably you can just search for references. Okay, and then put it. Now what is references? It means that suppose you want to synthesize this sample and you have tried to understand this from this particular paper. Okay, so that means this will be your reference paper. So you can write down references in different way. What happens in general in Google, it's very easy to write the reference format. Okay, so you can just say, let's say I've selected this paper, and then I have got some content from this particular paper. How do I write down references? I can just go here, okay, cited by, or I can just go here, sorry, cite. If I click on this particular, these two okay, inverted commas, you can see that there are different formats, okay, here. And this is the APS style, this is the MLS style, Chicago, Harvard, Vancouver. Vancouver is very popular, so what I do is usually I copy this. Let me just copy this Vancouver style, and then I will copy this, and then this will be the references format. So reference is the format will be same, okay. So example, reference example will be something like this. Okay, so you can use something like this as a reference example. Okay, so this particular section, you know what is this? This is the name of the authors. Then the title of the paper is here. The name of the journal is this. The name of the journal is this. Year and month of publication is this. Page is this. Sorry, this is the volume 108, and this is the page number. Okay, so this is how references are written. So if you are using too many papers and you are taking some examples from some paper, you can write references. Okay, a very important thing to note here is no plagiarism. So you cannot copy anything and paste it. You have to write down or okay. Try to do your sentence correction. Okay. So this is no plagiarism. Number one, maybe I can just write down this also. No plagiarism. Number two, I will just tell you, use tools like online tools. Okay, online tools like Grammarly. You have to register in that site. You have to do it, or even the free version is available. Grammarly for corrections. Okay, so you know sentence correction and all, you can use this particular tool. So if you are doing it, you do it the right way. Okay, it's very important, but like I suggest. So you can do the corrections using this. No plagiarism should be there, and then you should use online tools like Grammarly for corrections. Okay, so this is just what you need to do. Okay, and in the next meeting, I'm going to tell you how to actually write down your project report. Okay, and how to do the presentation. So this is not something which you'll do it now because you know you don't have time. So next meeting, I'm going to talk about. You have to submit your project, right? So that also you have to know. That means if you know from beforehand that what are the information that you need to write down in project report. A project report, something like a paper, a journal paper that you are going to study, the structure will be more or less the same. Okay, so that is the project report, but I'll discuss one by one the points. Okay, then presentations. So you basically have a lot of presentations, like 2 to 3 presentations with there. You'll be assessed, and the final presentation, your external will be there, and he or she will give you some marks, and based on that, you will be graded. So presentations are important. So how you're going to prepare that PPT and all, we'll discuss it in probably in the next meeting, because you know you have to prepare these things if you're doing. So I'll just save this. Okay, I think that's saved here. Just close it here. So that's it. Okay, that's how exactly we proceed with the project right now. Let me just stop the recording first.